Hi everybody, it's Mr. Hamilton here. Today we're going to look at one other example of Ohm's law applied to a circuit. Here we have a circuit with a 5-volt battery. Current's traveling out of the battery, we're calling that I source, IS. And then we have 4 resistors, 2 of them are in parallel and the other 2 are in series to the 2 parallel ones. And so in order to solve this type of circuit, what we need to do is we first need to simplify it and figure out what the parallel portion of the circuit is first. So we're going to do the parallel portion, and then we're going to have R1 in series with the parallel portion in series with R4. So let's see what this physically, or how we would calculate that. We know that 1 over R parallel is equal to 1 over R2 plus 1 over R3. Now each of those resistors are the same. So because of that, I don't need to even find a common denominator. I can just go ahead and add them together because they already have a common denominator. And so what I arrive at, my pens will work, is I arrive at 2 over 22 ohms, which is equal to 1 over R parallel. And 2 over 22 is 1 over 11, or 22 over 2 is our parallel. So that just ends up being 11 ohms for that parallel section. So now what I can do is I can say, well, if I go around a single loop, I go through R1, then I go through the parallel section, then through R4. So it's as though I can simplify the circuit like this. Here's R1, here's our parallel, here's R4, and then I'm back here. So R1, R parallel, R4. So I can write this out now as R total equals R1 plus R parallel plus R4. And that's really easy. We just add those ones up. So I have 22 ohms as every resistor. So I'm adding 11 ohms and adding 22 ohms. So I have a total resistance of 55 ohms in the circuit. So that's my answer for part A. And then part B, it's just asking the current through the battery. Well, we know the total resistance, we know the voltage, so we know that V equals IR. And in terms of this situation, it's the total resistance, the source voltage, and the source current. Then I can rearrange that to find IS. It's just going to be the source voltage divided by the total resistance. And the source voltage is 5 volts. The total resistance is 55 ohms. So this simplifies to 1 over 11, 55 ohms, which is, as a decimal, we would write this out as 0.091 to 2 sig digs. So the current is 0.091 amps coming out of the battery. Now I want to point out a couple of quick things here about this particular question. One thing I want to point out is that anytime we have parallel resistors that have the same resistance, what that's doing is it's cutting it in half if there's 2 of them. As you saw here, we had 22 ohm resistors in parallel, and that meant that overall it was 11 ohms. If there were 3 of them, it would cut it in thirds. So if we had 33 ohms to start for each of them, and we had 3 of them in parallel, that's how we get to 11 ohms. Now that only occurs if the resistance is the same, and we don't necessarily need the same resistance in parallel portions of a circuit, but it does help for that specific special case. Just so that we have a really good understanding of how this works, I want to take this a little further and I want to solve everything else in this circuit. So let's do that in the next few minutes here before we wrap this up. So we're going to solve everything else. Well, what don't we know in this circuit? I'm going to write it in blue. One of the things we don't know in this circuit is we don't know the voltage across here. We don't know the voltage across here. We don't know the voltage across here, the voltage across here. We don't know the currents through here. And we don't know the current through here. We know the currents through V1 or R1 and the current through R4 is going to equal IS. But so we don't need to solve anything for that, but we will note that those are equal to the current through the battery, or coming through the battery. So there's my circuit. I know that I'm trying to find all the values in blue, and we already know what I1 and I4 are. And my current I1 and I4 is 0.091 amps. More specifically, just it's going to give us some more exact answers. We did it by finding 5 divided by 55, so it ended up being 1 divided by 11 amps exactly. So that is IS, which is I1, which is I4. And now we can use that to solve some other values. If I look at each of the resistors, I need to look at it and I need to figure out, do I know two things? If I know two things, I can find a third, right? If I know two things from V equals IR, I can solve for the third thing. If I only know one, I'm not going to start there. I'm going to do the other things first until I have a second thing that I can solve for. So here we go. We're going to start by looking here at this first resistor. Well, I know what the current is and I know what the resistance is, so I'm going to start by solving for V1 because I know that and I know that. And then down here I know R4 and I know I4. So with those two things I can solve for V4. So that's a great place to start. If you look at V2 and V3, I don't know the current and I don't know the voltage. So I need a little bit more information. Now some of you who are really noticing this carefully, you're noticing that the resistance, because they're the same, that the current's going to split exactly in half. If that was not, if those resistances were not the same, it wouldn't do that. But here, it's pretty convenient. It does split in half. So you could actually solve that right away, but in general, you won't be able to. So here we go, V1, so the voltage across R1 is equal to I1 times R1. And we know that I1 is equal to a value of 1 divided by 11 amps. All right, and I'm using that exactly because what we'll see here is as we put in 22 ohms, it cancels out rather nicely because we get 22 over 11 volts, which is exactly 2 volts. So V1 is 2 volts. We do the same thing for V4. And we know it actually ends up being the same value, right? So it's I4 divided by R4, which are exactly the same values. So we get for V4, we get a value of 2 volts as well. Now, here's where we can solve for the voltage and then determine the current if we didn't know that it's split in half. Since we know that the voltage around any closed loop must be 0, Kirchhoff's voltage law says around any closed loop, the sum of the voltage equals 0. Then we can say that the source voltage is equal to the voltage across resistance 1 plus the voltage across resistance 2 plus the voltage across resistor 4. Right, a closed loop here is if we go here, and then we go to the left on that path down here, and then back through R4 and back up to the battery. That is a closed loop. And so in that case, we would, you don't need to do this because it's pretty intuitive, but we would know that this is 2 volts. We know we're trying to solve for V2, and this is 2 volts. So rearranging that gives me 5 volts minus 4 volts. So that means my voltage across that second resistor is 1 volt. And now, because that is parallel to resistor 3, that means that the voltage across resistor 3 is also 1 volt, since parallel. To R3. And we have all the voltages. The only other thing we need is the current. And as I noted already, there's one way to do it that's pretty intuitive and pretty straightforward in this particular case. And that is just to divide the current in half, because it's clearly going to split in half because the resistors are the same. If the resistors were not the same, the voltages would still be the same, and we could then, from those values, find the current. So I'm going to use that method right now. I'm going to say that I want to find I2. I2 using Ohm's law is going to be V2 divided by R2. We know that V2 is 2 volts. We know that it's 1 volt, not 2 volts, 1 volt. And we know R2 is 22 ohms, so it's 1 over 22 amps. And if we go 1 divided by 22, this one's still jumping around on me here, 1 over 22 amps, that's the same thing if I divide that out as getting 0.045 amps. So we could say that's equal to 0.045 amps. And that is in fact also equal to the current traveling through I3. We could use the same calculation to find that, or base it off the reasoning that because those resistances are the same, the currents are going to be the same. So there you go. That's how you would solve a problem like that. There are a number of different scenarios we could look at, but that's the basic structure using Ohm's law and using Kirchhoff's voltage and current laws. So I hope that helps. If you have any questions, by all means, reach out for help.